Hello and welcome to another episode of my devlog while I document my efforts at attempting to create my first Mega Drive game. We'll start out with a very quick progress update on what my game looks like so far. So folks who have watched my previous videos will recognise this intro screen. So the main thing to demonstrate here is that we now have a cursor which snaps to a map tile. And you may also notice there's this little green dot that's supposed to be a small projectile tower, one tile in size. And I've also implemented code to switch between cursor modes. Now the sharp-eyed among the viewers might notice that the snapping is a little bit different on the tower. So the idea is the tower snaps to the tile neatly because we want to place it fully encompassing the tile that it's hovering on. But if we switch back to the cursor, you see in the top left corner, that actually is offset a little bit. And the idea being I want that to point to the center of the tile so you can see what's in there. What's missing, however, is any placement code. And before I add the code to place towers down on the map, I want to implement a check to see if the spot that we're hovering on will let us place a tower there. Now there's going to be two key things to keep in mind. There will be places that we can't place towers because there's terrain in the way, like when we load up the map for the first time. We'll also need to keep in mind that if we place a tower down on the map, then it's going to take up one or more tiles, and those tiles will need to be marked as no placement. So you can't put anything down there because there's already something there. Now what I have in front of me is a text editor that's opened up one of the TMX files that I created with Tiled. Of interest, we want the object group, which is where I put tiles into an object layer in Tiled D. And now in Tiled, you can insert objects or tiles on object layers at any XY location of the pixel resolution. But because I wanted to use a tile-based granularity for collision detection on whether you can place anything down on the specific tile, I made Tile D snap to grid when adding tiles. And rather than continue explaining that poorly, I'll just show you what I mean in Tiled itself. So have our object layer visible where we've got this special red tile we're going to use as our marker to say that, hey, this is occupied by terrain where you can't place anything. And I can use the insert tile, which is this button up here. At the moment it's snapping to the grid because I've set it to do so, so I can disable that. In the view menu I can find snapping and disable, so I could place this tile anywhere in the object layer that I'd like. But that's not really going to help me when it comes to using the object layers to map out tiles that things can't be placed in. So that's why I just have it snap to grid, and there we go. No placement tiles can only be placed in actual tile regions. So I'm considering asking ChatGPT or some kind of AI LLM to assist me by writing a tool to basically take this chunk of XML and turn it into a C array that I can use for my collision data. It is also worth quickly considering a few aspects of the data that we might want to store in this map. We should have an in-ROM terrain map, which will be created in Tile D or Tiled, and that will get loaded into an in-RAM sort of tile occupancy map is what I've been calling it in my head and bits of code so far. So that tile occupancy map at level start will get loaded from the terrain map in ROM, and then as we're placing towers we're filling that in. Now we'll just jump over to the IDE to put in some example code, and I'll probably combine this with some very bad drawings to demonstrate my ideas here. But we want to indicate that whether we can put something into a tile on the map based on terrain data. Okay, so we'd probably want to have an array of bytes, and we will call this tile occupancy, because it's to indicate whether things will be occupied as well, and if it's occupied then it can't be placed. So that's going to be an array of 30 tiles by 28. We could load that up with a bunch of ones and zeros to indicate that that there's sort of terrain and a tower can't be placed in a given tile. But if you think about it, we only really have one bit of information to indicate 0, there's nothing occupying the tile, or 1 to indicate that something is. So if we use this badly drawn collection of boxes to indicate the bits in a byte, or an unsigned 8-bit value, and let's say we want to, blue, there's something there. There's 7 other bits of information that aren't used. If you were wanting to store a large amount of just binary information about a large number of tiles, you could replace the array of bytes with a bitmap, where you use a little bit of logic and bit manipulation to translate an X and Y coordinate, which would be an array value, into a specific bit within one of the bytes of a far smaller array. And because there are 8 bits into a byte, if you're doing that, theoretically you could easily shrink your memory usage by 8%. By 8. So the bitmap is one possibility, and I did consider that briefly, but as we'll see in a moment, I do want to use the bitmap idea elsewhere, but I do still want to use a whole byte for each tile's occupancy information. So start out with these 2 bits, and let's say they're bits 6 and 7. Now I'm doing the most significant byte on the left, which is why 7's coming before 6 here. What we could then say is that indicates occupied. In particular, bit 7. 0 is unoccupied. 1 is equal to occupied. Okay, so why 2 bits to indicate whether it's occupied or not? Well, if bit 6 is, let's say 0, then we could say that's terrain. So that means it's a hard-coded, that tile has something in it that you can't do anything about, and that would have been loaded up in the initialization from ROM to the occupancy array at level load time. So terrain, it's a hard pass, you just can't do anything about it. Or 1 is, you could say, user placed, i.e. a tower. And that would mean that you could destroy that block. I envision that the game will probably have 2 modes, so there will be select mode and place mode, where select is you're going around the map and you click on an existing tower to get information, upgrade, maybe sell it to get some cash back. And then there'd be place mode, where you select what kind of tower you want to place, and then you draw around the map and hit the spot you want with the cursor, hit the button to place a tower. Let's take the example of we've placed a tower down and we want to destroy it. Well then, what do we do? How do we track down what tower object in our game memory we're looking at for this given XY tile on the playfield? So my thought is that bits 5 to 4, 5 to 0, 5 bits, making for 32 values, that could be the tower ID. Now this, of course, would mean that if we take this approach, then the game would be limited to only 32 towers, but that's probably a good strategic limitation, and probably, I'm not entirely sure yet how I'm going to manage the data structures for towers that are existing and in play, but keeping it limited to 32 is probably overkill, but I think that's a good start. We could always reduce it if we wanted to. And I've just realized now that I've highlighted 6 bits there. I actually want bit 4 to 0 inclusive, of course. Now, an interesting thing to consider is if we're adding and destroying towers, how would we, and we can only have up to 32 of them, could we have a simple way to know or store like available tower IDs? And I think we go back to the bitmap idea. If we have 5 bits available for tower ID, then that means 32 possible towers. If we want a quick way to see what tower IDs are available, what we could do is we could take a 32-bit unsigned number and use that as our bitmap like we discussed just before. If we want to find the next available tower ID, if we've been placing and deleting stuff like crazy, then we can just start from the least significant bit, bit 0, until we find the first bit that's 0. And then, okay, we take that as the ID for our tower, fill it into the tiles as appropriate, and mark that bit in the available ID's bitmap value. Now, as for asking AI about help with the script, the problem I have, or the challenge that we have, is that I only want 30 by 28, and there's 10 to the left which are just to be discarded. So, So I'll probably put that in another video. I want to have a bit more of a think about that and a bit of a probing around. It's also actually getting quite hot here where I'm recording tonight. That's my thoughts on what we'll do for tracking, for working out where we can place towers, where towers have already been placed, and how many towers and also limiting and tracking how many towers we have available to place. I'll cut this video short for now, and I'll see you in the next one. Bye.